Morning.
Yeah, good morning. Hello, team. Welcome to our next IBMI training session presented by Programmers.io. And let me introduce myself. I'm Mohammad Hussain, having 1.5 years of experience in IBMI, and I'm the moderator for today. And today's training session is all about binding directory, and it is taken by Mr. Rahul Parekh. Let me hand over the session to Mr. Rahul Parekh.
Thanks, Mohammed. Hello everybody. This is Rahul here. So yeah, today in the previous session we had discussed about the modules and how this modular approach and the ILE addition to the IBMI ILE writing the programs with the ILE concepts helps your programming in a modular way, reduces the efforts, makes your code reusable, and it makes or tries to make the efficient use of the resources available onto the system. So I last time when we concluded the session, I think we had just the overview of how what the service program is and how do we create the service program. So just a quick recap before we just go into the session. Service program is is a is a one of the type of the objects on the system which has or which gives the ability so that you can have your code placed at one place and then you can use it at multiple places. It's kind of a wrapper which can have service programs or modules. So it is a group of modules. You can club maybe 5-10 modules or service program into one service program. Generally good practices, you one has to put the modules related to each other into one service program, and then you can use that service program into your main program wherever you want to use the functionalities written into the service programs available modules through sub procedures. So I'll share my screen. Just let me know, Mohammed, when it is available to you. Is it available?
Yes, it is available, sir.
Okay. So we'll start with how do we create service programs and how do we use the service programs. So I think in the last session we tried to create one service program. So let me go back to that. So here we have this source code, which is a no main thing. You cannot run this. So it is again have those sub procedures documented here with their procedure interface and the definition and the logic what we are going to do into these sub procedures. So you can see we have these four sub procedures here: get the count, get the salary, update the salary, or delete the employee. So to create a service program, first of all you have to have a module. So what I'm going to do is I'm going to create a module with this. It will so when you want to create a module, it will run the command, and I can now I've created one module here. So there was so now let's try to create a service program. To create a service program, we have the command crtsrvpgm, which is a create service program command. So if I write here, so here one of what it has is it will take the name of your service program, the library where you want to create the service program, module, which module you want to create, and then you can add multiple modules here. So if I put For example, here with the name of the module, you can attach multiple modules here. So it will give me, so this is why we use the service programs. If you have to have, for example, you have 10 modules or 5 modules or maybe more than one module, then if you try to create a program of your with those more than 2 3 4 modules, then you have to write all the modules name when you write the command cit pgm. To reduce this effort, what we can do is we create one more in between kind of wrapper or container, you can say, that is called service program. So what I can do is I can add all my modules into this service program, and while creating the program I need to mention the name of this service program only. So all my modules are available into this service program are at my program's disposal. So that's why we create the service programs. While when you create a service program, this is one of the important parameters. Okay, export, I think I mentioned this in the previous session, that we'll go and we'll have a look at this again. So when you create a service program with this name, I'll have a same source file in this source physical file, and in your that should be available in your library list, because it says the source member that you are creating, it should have the same name with your service program. Okay, so before we go and create a, or let's try to create this service program. If I create this service program, okay, let's see what is the issue. So now my service program has been created. Okay, last time in the previous session we checked, you can check the attributes of your service program with this. So if I check what are the attributes of my service program, I can use the command dsp-srv-pgm. It says the export or the attributes will be taken from this source physical file and from this member. So we'll go to this member, what it has, and then you have the current export signature. What the signature is, I'll tell you. And now we can see that this service program gives us these 4 procedures which can be used outside this service program when you attach this service program to your program. So I can call these 4 procedures from my program, and I have 2 signatures here. Why do I have 2 signatures here, and what is a signature? So let's go and understand this. To understand this, let's go to this source file, which is kind of a text file. So this is, we say it's a binder language which defines the attributes of your service program. Okay, now you can see that it has only 3 commands. It start, this is a start of the program export, end of the export, and then it defines which export, which modules, sorry, which sub procedures it will allow to be used outside the word of this service program or outside the boundaries of this service program. Okay, so let's, because I have written here two two set of this export commands, that's why I have, while compiling the service program, after compilation I got 2 signatures, because this defines the export attributes. This has one it is responsible for one signature, and this export set of lines or binder language is responsible for the another set of signature. Okay, now why do we have 2 signatures here? So to understand this, let's go back to our module. We'll go by one by one. Okay. For now, what I will do is I will take this out. Now, why I have taken this out is I'll show you. So now I have, and let's say change it to current, or now what I'm going to do is here you can see in the previous session I explained that when you put this keyword export, then your whatever your procedures or variables you have defined, then it is available to be used outside this code. So you can see I have 4 procedures here. Okay, count, salary, update salary, and deletion of the employee. Okay, and I have put export on all of these procedure interface. Okay, so I make sure that this is available outside the world. Now let's go and create the program with that service program, or let's create the service program again, because we have changed the binder language. So I'm going to create the service program again. Okay, so now you'll see if I again check the attributes of my service program, you'll see that only these 3 attributes or these 3 procedures are available for the export, because I have removed the second block of export definition that was allowing me to export one more sub procedure out of that service program definition. But now I have only these 3 sub procedures which can be exported or which can be used outside the service program, and I get only one signature. This is my signature. Okay, so that's why while when we were creating the service program in the previous session, I mentioned that this binder language source file, it defines or it controls what attributes are available outside this service program. That's why when we run this program, when we ran this command, we say to the system that while creating the service program, take the attributes of the service program from this line. Now there are 2 ways. Either, since I have put export and export definitions I have put in this member, that's why I have put here that what I need to do is you have to take export attributes from the source file, and from which source file, this source file which is available into QSRV and the member will be service program name. What I could have done is I could have done, or I could have taken this attribute star all also. In that case, one need not to write this binder language. But what are the benefits and why do we use this binder language will come later. So now I've created my service program again with 3 sub procedures. Okay, let's try and create the program. How do we create the program with service program? Okay, so this is my program. Okay, I have 3 procedures I want to use from that service program. Okay, let's run the command to create the service, or to create the program with the service program. So again, I'm using the create program command, my program name, and now instead of in the previous session we were giving the module names separately to be used with this program. Now I'm giving my service program name which I want to bind this program. So if I run this command, my program will be created. Okay, and if I call this program, it will work fine. What it will do is it will run and it will do whatever it is intending to do. So it is doing some getting the total salary and some logic it has done. Now it has worked fine. So this is one of the another tools that ILE gives us. Initially, we started with a simple program where every logic was into one source file. Then we made it modular, but that was again inside the boundaries of that your source code with the help of procedures. Then we took those procedures outside into another source file that was created with module. And now we have taken one more step ahead. Yeah, out of those modules, we have created service programs. Okay. So this is how with this modular approach you can take. Now, what are the benefits of this service program? One benefit was like you need not to give all those modules while compiling this. You can put it is kind of a wrapper. You can use this service. You can use this service program and put all the modules here. And let's say, what if I have to, for example, if I have to add some logic here, for example, I have to add a logic here. I want to display or I want to run more one more SQL here, right? Until and unless you don't need or you don't change the interface of these prototypes or procedures, how it will get changed. For example, currently I don't have any parameters associated with this. If I add one more parameter here, okay, or I add one more procedure here. There are two cases. I can add one more procedure here because now I want to need that. I want to update my employee also. Update with salary. I want to update my employees also. Okay. Or what I want to do is currently I have this is doing only for employee ID 2. I want to do it for maybe I want to pass an employee ID. Okay. So I can pass a parameter to this procedure from my program. Okay. Unless you don't change the procedure or prototype or procedure interface of your service program, whatever the commands you write here, whatever the extra logic you have to you write here, you can write here, you can create the service program again, and you need not to compile your program again, because your service program, if you change the interface of your procedure which you want to call from your program, then you will have to change your program also, because if I put one parameter here, then while calling this procedure sub procedure, I need to add one parameter in my existing call here. Then in that case, you'll have to compile your program. But if I don't change anything here, I just write some code here, I need to just create the module again and just attach it to the service program again. Nothing. Then now, for example, now you can imagine, let's say this count is used in 10 programs. Okay. So at this case, if I don't change anything in my program, what I will have to do is I will have to put my logic here. That's it. And I need to compile this module again and attach it to my service program. Or if this is the only module in my service program, I need to create my service program again. That's it. All the programs that were using it, they need not to compile again, because the new functionality, the new code you have written here, they will continue to use it. Why? Because you have not changed the signature of your service program. So whenever whatever module sub procedures you write here with export, let's say you have written 5 procedures with export, and in the binder language I have allowed my 3 procedures to be exported. So system will take the binder language into consideration and it will create the signature of the service program. So since I have not changed the binder language, I have not changed anything. I've added some additional functionality in one of the sub procedures. Signature of my service program remains same. So the programs that were compiled using this service program will keep on functioning how they were doing before this change. So this gives us the functionality, because had I not put this here and this logic was available, let's say into 5 programs, what I had to do is I had to go to all those 5 programs, make the same line of change in all those 5 programs and compile them again. So that's what I mentioned in my previous session, that either if you want to change a single line of code, right, and when you compile, but you will have to compile a big program which is maybe 2000 line of code. So to change one line, you are making or system resources that will compile 2000 lines. What I can do is I can put that here and I compile one thing. That so this is kind of feature service program provides us. Okay, so now with the service program we get generally errors, that signature violation error. So what that signature violation error is? Signature violation error is something, in the previous session we had explained, one of my colleagues had explained that when you create physical files or the database files, when we change them, some, or you add a field or you remove the field, then system changes its identifier. Similarly, when you change or when you add some new procedures into a service program definition, then system, because something has been changed, system will create a new signature. Okay, let's say it was previously the signature was S1, now a new signature will be created which will be S2. So the program which was expecting something identified with S1 will not be able to find that because that has been changed S2. So program will give you an error that I'm not able to find my S1 signature. So it will give you the error that is called signature violation. So what we are going to do is, to encounter that, what we can do is, okay. So what I'm going to do is I'm going to export my new procedure here. And what I will do is I'll create my service program again. So now my service program has been created. Okay. I have not compiled my program. Now let's try to call this. So it will give me error found on call command. So what error is this? It is saying program signature violation. It means when you made one more procedure to be exported or available to outside world through this service program, the programs that was using the previous state of the service program now is not able to use because the state of your service program has been changed. That's why in the binder language we put previous or current. Okay, so this is in a system where you can have, or you, a system which has been developed over the years and you have introduced some of your service program into your system, then what it does is whatever, and you created one, or one has created maybe 2 3 4 service programs, and let's say at a given point of time maybe 25 30 programs are using some of the features out of these service programs. So if I need to change or if I need to add some more functionality, that I see that this part of logic or piece of code I need to put in my one of my service program, so that again it is available to those 25, out of those 25 maybe 5 the existing programs, and I'm going to write 3 4 new programs which will be using that functionality. Then if I create or if I add a new sub procedure into this, and when I will compile my program, the older programs which were not aware of this new sub procedure will fail because they are still known to the previous state of your service program, right? To encounter this, there are two ways. One is to compile your all the old programs again, or one is to manage it. That system gives us the functionality or a feature that we can manage it. To compile all the service or to compile all the programs is not a feasible option. So to reduce this, what we need to do is we'll have to just give me a minute. Okay. So to handle this or to encounter this situation, what we are going to do is we are going to make some changes to tell the system that, hey, you have to take this attribute also into consideration when you create my service program again. So how do we do that? Our Binder language. Ah, this current is whenever you write this kind of export details, your binder language can have only one current signature, because current is always one thing, right? Everything is something was behind or something that is going to come, but current is something. So what is the current signature? When you have this, you can write only one current statement with the current export, and then you can have multiple previous thing. So what I will do is here, so here, and I'm going to put some more lines that we had already, we took it outside from this. What I will do is I will put here and I will remove this. So what does it mean? When you make this kind of changes, when you add some new functionality, new procedures into your service program, what one has to do is one has to maintain the previous state of your service programs. And how do we maintain it? We maintain it with the help of this binder language or binder source. So for that, why? Because earlier situation, let's say it was with three procedures. Now I have created or added one more. What I have done is I have created a new binder export or export statements in my binder language, giving it with the current status, and what was the previous state, I will take it to previous. So now I have made one change, and I've told or I'm guiding or I'm just instructing my system that when you create my service program, just maintain the previous state. So the programs which were aware of the previous state, my program will keep on running. I need not to change them. And the programs which I want to create after the compilation of the service program, they will be known or they will know the current or the current state or the new state of your service program. Now, so let's change this. And again, what are we going to do is we'll compile the service program again. And as in the starting, we saw that when you have this two export available in your binder language, you will get two signatures. Okay. So, uh, I'll see that these procedures are now available. They are available with the help of these two signatures. So this is a previous signature and this is a new signature. Okay. Still, if I call my program again, because I have not changed my program again, Now it will work fine. So by this way, we have resolved the signature violation. Okay. So this is one of the way how you can resolve or make sure that your system should work how it was before this change, addition of new logic into one of your service program, and the new change or the after change should also work. The another thing is what you can do is one can create a service program, because everything we are talking about is about the signature. So I can do another thing is I can create my service program every time with some hard coded signature, maybe some test or for employee. So even if I add some new procedures into my binder language to be exported, every time the signature will be test or test one or test two or test three, whatever you want to do. So the programs which were known to my service program with the test, after with the new implementation of procedure or logic, again it will be created with the same signature. So you can one can hard code the signature here. I can put here, I can mention that signature is maybe XYZ. Okay. But a good practice is always is, even if you're creating a service program with hard code signature, the good thing is always add your new export or new procedures that you want to export at the bottom of this, so this sequence does not get changed. So while when system tries to resolve the export, it can find wherever it was earlier. Okay. So what I can do is, instead of this, I can put my some test or XYZ signature. And I think in the previous session we created one service program with the hard code signature that is called, I think it was test or something. And with that approach also, your program signature will always remain same, and your programs will work how it was working before the change, and your no, new programs will take care, or they want to use the new functionality. Okay. So this is how you create your service programs. This is how you create your programs with the help of the service programs. Okay. Now, while we were creating the modules and all in the previous session, there was one thing, because there is one more thing which is called binding directory. That is again one more step down the line to have a. It is again a kind of wrapper which can have your more than one service programs into it. So I'll come to that later. Before going to that, let's talk about the activation group, because in the previous session when we started, I mentioned that all your programs, that ILE programs, cannot be compiled into activation group, which is a default activation group. Okay. What does that mean? For example, when I log into this session, everybody knows that we have mainly two kind of jobs, which is interactive job where I can give some comments, and there is a batch job which does not need my intervention or a user's intervention. I just instruct it, give some command, and it will run in the batch background of the system. When it encounters an error, it will stop, it will wait for a user's intervention, else that batch job will keep on running. So everything what we do in terms of system is a kind of is in the form of job. So this is one of my interactive job. Okay. This is my, when I sign on in one more session, then one more interactive job will be started. Okay. So if you see, there is a command here, there we have some options. Out of this, there is an option to display the activation group of your job. Okay. So if I take 18, you'll see this is default activation group. Okay. So whenever a job is started, system creates one activation group, that is a default activation group. Now, in terms of what is activation group, what I know, or wherever you will search or go through the documents, you will find it has been defined like this, that activation group is kind of a container, or container which gives helps in activation of your program, allocates the memory resources, and makes a environment available for your program to run. Okay, so when we start this job, system creates one activation group that is called default activation group, and that default activation group, what IBM document says, or whatever, if you, or when you look at the document, it says that mostly this default activation group is used or so that system can run the OS programs. Okay, because whenever you type a command, whenever you run a command, there is always a program running behind that. That is a system program. When we say that's a system program, and to run that system program, they need some container where they can allocate their resources, release their resources, or do something whatever they want to do. So for that, system has given the activation group that is called default activation. Okay, apart from these default activation group, we can have some other activation groups. So if I can see in the, when you create a command or when you try to create a program, there is a parameter activation group. Okay, here it has some parameters. This is entry module. Let's leave it for now. You can have a new, a caller, or you can have a name. Okay, so what does that new means? New means is that whenever your program will be created, and if you create a service your program with activation group parameter value as star new in a job, if you call that program, okay, what system will do, it will check what is the activation group. So if it is a new, system will allocate a piece of memory, or it will create a kind of container for this program to be run into that. Whatever the memories resources are required for this program to be executed, they will be done into that container, or into that piece of memory or heap. Once you are done with this, once this program execution ends, that activation group is vanished and we are done. So for example, if I run in this interactive session and I compile a program, so let's do that. What I'm going to do is, see, let's create a program because we did not compile the program. So let me create it again. Here, what I've done is I'm creating a program with a service program that we just created. And now activation group is my new. Okay. So let's see how it works. My program has been compiled. Okay. So if you see now, currently I have activation group only, default activation group for this job. I'm going to show you in the debug, because once the program ends, we cannot see how this new activation group works. Okay. Okay. So let's call this. Okay. Now my program has started, and now if I check into my job, this current job, you will see a new activation group has been created, which will run my program this from this library. Okay. So what system has done is, it has, once this program was called, its execution started, system has created a piece of memory, giving it some name or kind of container, and your program will run into this. Okay. This is how, and if I do something, I'm done. My program execution has been done. Now, if I again check it, that activation group is gone. So this is how new activation group works. So every time, if I call it again, if I call that program again, earlier it was 65, maybe this time it can be some other thing. So if I call it again, you will see a new activation group has been created with the number 67. So every request into this job or every request of this program will create a new activation group. Okay. This is how a new activation group works. So this is how my new activation group works. So whenever you call a program, system will allocate new resources, and once it is execution ends, system will release those resources, or it will reclaim that activation group. It means it will end that activation group. Okay. Now let's go to some other parameters. We can compile the program. Now let's try other activation group to compile the program. Here, let's try to do. It was new. Okay. Now let's try to create a program with service group, activation group EMP. Okay. My program has been created. Okay. So if I call this program again, okay. What? Let's check now what system is created. We'll see system has created a new activation group, that is EMP, and it is running my program into this activation group. Okay. But the difference of this activation group when you create a named activation group is it will be active until your job is active. It will not be reclaimed, or it will not be vanish. It will not vanish. System will not just remove it until your job is active. So if now I check, once that activation has been group has been created, I can see it is created, right? Correct. And it will be active unless I sign out of this session or in a bad job. So for example, if I call this program again, system is not going to create a different activation group. It will run this program into that same activation group. Okay. So why do we have this different parameters of this activation group? For example, if a program that runs once in a job, it is okay that you create a different, or you compile it with the new activation group so that it has a separate fresh memory space for it. It does what it has to do and then comes out, that activation group is over. But for example, in a program, if I need to run a program maybe 50-60 times, and I compile my program with a new activation group, I'm putting an overload into my system, or a kind of overhead, that every time before it is called, you have to create or you have to prepare a new memory or a new container for this program to run, which can reduce your efficiency of the system, or maybe that job can take a longer time. Some similar to like that, when you create a program again and again, system has to prepare it for that execution, putting that into the call stack. Once that is done, release the resources, then come back to your program from where it is being called. So the thing is, if you create a program and if it has to be run maybe once, created with new, if it has to be run multiple times. For example, in a web application on uh, we can host some websites on IBMi, and for those website there are some jobs which keep on running. Okay. So that job is again that is a bad job, but So if I create a program, for example, if I call this program and I created this program with the name activation group, so what system will do is system will create into that job only once, and whatever the web request wants something to be done for that program, system will not create a new activation group because that has been created on the first call if that job served that web request, or maybe in your batch job. Okay, now I can show you what does it make a difference. So let's say, let's change our program bit. What are we going to do is, we end the session. Now you can see I have defined a variable here. Okay, and every time I call this, what I'm going to do is I'm going to increase the number of time it has been called, this program has been called. Okay. And here I'm not releasing, I'm ending this my program with the return. I'm not doing INLR on. So how does it make a difference? Okay. Okay, so now I'll compile my program. Okay, and activation group is, let's say, I think it was EMP. So EMP has been created. Okay, and I call my program, or let me show it to the debug. We'll see. So my this value is 1. Okay, now I call it again. Memories are there, it has not resolved. We'll see this value has changed. It is 2. I'm calling this program. Okay, I'm calling this program again and again into that same activation group. Memory is same, and I'm not releasing it with LR because I'm going back to this program with return. Okay, so this memory remains active, and it can give me how many times this program has been called because it is into that same memory space and that is available. Okay, so this is how it makes a difference when you take care or change these parameters, and when we say how this IN or this last indicator works, how this return works, and how these memories are allocated. Yeah, so this is we have I think covered new and named activation. There
Rahul,
is
one
another.
question.
Yeah.
Yeah, hi, this is Mahesh Rahul. So if we are giving that activation group in the create PGM, right?
Yeah.
And we are also mentioning in the program itself in the head spec, correct? So like if we give in the head spec, we don't need to give in create PGM, right? Or
Yes.
both are required?
No.
Any one is required, right?
Yeah. Yeah. You can give, like, similarly, you can give your this binding directory is also in your HSpec.
Correct.
Instead of putting that binding directory while doing this compilation time, you can put on the HSpec. Yeah.
Yeah, that's right. Thanks.
Yeah, this was for the activation group new. Now there is one more thing that is called caller. That caller means your program will be called. Your program will be called into the activation group of the program which called this program. So, for example, the program that I'm running, if it is being called from program P1, so this program will run into the activation group of that P1. So now this point, this parameter makes available that your ILE program can still run in the default activation group. Because though you cannot create your ILE program with the default activation group, but still you can run your ILE program into the default activation group. How? So let's say I created one program, which was my OPM program, created 10 years back, simple program. I have added a program, I have added a call of this new my program, which is an ILE program, which uses sub procedures and all ILE features. And I've created or I've compiled while creating that program. I call this compile this program with star caller. So what it will do is, because your OPM will always run in the default activation group, this program, since being compiled with star caller, again will run into that default activation group because OPM has been running on this. So both of your OPM program and your ILE program will keep or will execute into the same activation group. So this caller is nothing. It will take the parameter or it will take the activation group from where it has been called. So one can create a named activation group, one can create the every time a new activation group or a caller. And if you see, I can show you one more thing. When you create a service program, this also has the parameter, that same parameter. And it has a parameter by default, it is a star caller, because service program is it is not a non-executable entity, right? You have to call it with from some procedure. So by default, we get this parameter that it will be called into that same activation group where I'm calling this. So it by default it takes that parameter caller, and your program, while creating your program, you can check. I think it by default it gives star new because it take, and then one can change whatever yes, entry module. So this is how this service program handling is done. If the program runs independently and not required to be run in the job again and again, start new is a thing that one can use. If you have to run, for example, your two programs are running and you want to use multiple files into the same program for like you have changed some attributes of your files and you want to use into your RPG with the over dbf commands and all. If both the programs are compiled in different activation group, that won't work because they are into different memory space. There is no relation into it. Your the attribute that one changed in the previous programs or the previous execution will not be used into that. So depending on the situation, how your program is going to work, one has to decide that what parameters I'm going to supply while compiling my program. This is of this related to the activation group. Yeah, this is regarding activation group, the thing I wanted to share. And now there is one more thing you have while I just talk. When we were creating the service program, there is another thing that is called binding directory. Binding directory is nothing. It is a collection of service program. You can create the binding directory and then you can add the service programs into it. And when you compile it, you can give that binding directory at the compilation time. So what is binding directory? To create the binding directory, there is a commands create binding directory. Here you can give what is the binding directory name and in which library you want to create that binding directory. Okay. For example, I have created one binding directory. Here I have created one binding directory. Okay. It is in my library. One of the object, it has two service programs added here. One is EMPSRV type of service program, and you can see that since we changed this, we created this service program today, so it is today's date. Okay, and this is another service program that I created just to add here. So this way you can add this, you can remove the service programs into this binding directory. How do we use now? while it is similar kind of thing, to give more than one modules creating at the program time, to make it easier, you put a service program. To give more than service programs while creating your program, multiple attribute values, to make it easier, we have one more feature which is called binding directory. So if I create a service program, create a module, create a service program, put them in the binding directory, I can directly use that binding directory while creating my program. How to do that? Here, these two lines that I had commented, now you can see that my program, I can give my program will not run into default activation group. I can give that the question that just Mahesh discussed. I have instructed that I don't want to create this program in the default activation group. I want to create this in this. And while compilation time, I take this binding directory into the consideration when I compile my program. Okay. When you have this, what you do is, for example, if I remove this. Okay. So if I save it, save, and now I can create my program with this also, because now my system knows that from where I need to pick my modules. So this is how we can use binding directories. And still, now what I've done is I've created this program with 14. I have not given any modules while compiling this program, but still I can use those modules or the sub procedures into those modules because they are available in my binding directory, and I have made that information available into my source itself. So I can use that, my service program features, my sub procedures through binding directory, then service program, and then sub procedures. So this is how binding directory is helpful. You can put multiple information, multiple service programs. No need to mention them separately. Put them into binding directory and just use it. Yeah. So I think this concludes my from my side, Mohammed.
Yeah. Thank you, Mr. Rahul Parekh, for such a grateful session, and hope you have covered all the concepts related to the service program and um, signature violations and binding directory and activation group. We have a query from teammate.
Mhm.
Yeah, uh, one of our teammate have just asked a query. If a service program is created using export all to handle signature violation, should we create binding source again?
If you have created your service program with export all, then in that case you'll have to, and if you change your service program, okay, you add one something you have changed, maybe you have added or add, and still you create with star all, your service program signature is going to change. Okay, system will not consider your changes or the previous state. So to make this, and with this thing, what happens is you go, every program that was using it, it has to be recompiled. So to make this situation or to handle this situation, that's why we put this what you call binder source. So from my what I can do is, let's say it was created, I think this was the question, that it earlier it was created with export all, and then I can I create it with binder sources. So if that was the case, then yes, I think you have to put whatever the procedures were exported earlier, you have to list them with the binder, and then create with the previous one and make one more binder source available into that source with the new. So that way, I think because the number of exports remains same for the previous, and for the new it can change. I think that way we can handle that.
Sure, sir. Thank you so much. So we have cleared with that, and in future, if you also get any more queries, you can reach us and in the comments. So thank you for such a grateful session. I think so we can wrap up.
Okay, thank you. Thanks everybody for your time.
Thank you.